What if I told you that rocks near the highest point on Earth contain evidence of an ancient ocean? Mount Everest rises more than 8,800 meters above sea level. It's a world of snow, ice, freezing temperatures and air so thin that humans struggle to survive. Yet high in the Himalayas, scientists have found rocks and fossils connected to ancient marine environments. So how did evidence of sea life end up near the roof of the world? Did the ocean once cover Mount Everest? Not exactly. The real explanation is even more incredible. The ocean didn't rise to Everest. The rocks that became part of Everest were pushed upward from an ancient marine environment. More than 100 million years ago, Earth's map looked completely different. India wasn't connected to Asia. It was located much farther south. Between India and Eurasia stretched a vast body of water known as the Tethys Ocean. Marine organisms lived in these waters. When they died, some of their remains became buried within layers of sediment on the sea floor. Over millions of years, those sediments hardened into rocks such as limestone, preserving evidence of ancient marine life. But then, India began moving north. The Indian plate slowly approached Eurasia. As the distance between them decreased, the Tethys Ocean began closing. Much of its oceanic crust was pushed back into Earth's interior. Eventually, tens of millions of years ago, India collided with Eurasia, and that's when something extraordinary happened. The continental crust was compressed, rock layers folded, the crust became thicker, and enormous amounts of material were pushed upward. The Himalayas began to rise. Imagine pushing both ends of a rug toward each other. The middle wrinkles and rises. Earth's geology is far more complicated, but the basic idea is similar, except instead of a rug, entire sections of Earth's crust were being deformed, and over millions of years, the result became the highest mountain range on Earth. This explains why rocks with a marine history can now be found at extraordinary elevations. Near Mount Everest's summit are limestone layers formed from sediments deposited in ancient marine environments. Elsewhere in the Himalayas, scientists have found fossils of ancient sea creatures, including ammonites, animals with spiral shells that once lived in oceans. But there's an important detail. This does not mean Mount Everest existed at its current height beneath the ocean. Everest didn't exist in its modern form when those marine sediments were deposited. First came the ocean, then the sediments, then the rocks. And millions of years later, plate tectonics pushed those rocks upward as India collided with Eurasia. And this geological story still isn't finished. India continues moving relative to Eurasia today. The Himalayan region remains tectonically active, which is one reason powerful earthquakes occur there. At the same time, wind, ice, rivers, and landslides constantly erode the mountains. So when you look at Mount Everest, you're looking at much more than the highest mountain on Earth. You're looking at evidence of an ancient world that disappeared millions of years ago. A world where India and Asia were separated by an ocean, and sediments containing traces of marine life accumulated beneath its waters. Earth eventually closed that ocean, collided two continents, and lifted some of those ancient marine rocks kilometers into the sky. That's why evidence of marine life can be found high in the Himalayas. The ocean didn't climb Mount Everest. Earth lifted the ancient ocean floor, and over millions of years, the bottom of a sea became part of the roof of the world.